Greetings, class, and welcome back to Lab 4 for 4670, CIS 4670. Last time in Part 1 we left off right after 1, 2, and 3, which was the hard part, if you will, for doing this lab. So the rest of it, believe it or not, 4 through 12, is going to go pretty quickly. So I brought the lab back up, and we're just going to go through this one by one. So on R1, we need to configure and apply an ACL to prevent those private networks, those RFC 1918 networks, from being sent out to the internet. So the best place to put that would either be an exit interface here, so you can write one ACL because we need to stop it from here, or we can put it on the inside here as well. So I would suggest we put it as an outbound on this interface. So remember though, we're going to have some conflict there because we had put some routes in these. So if we come to having a problem, we may have to come back and adjust that ACL. So just keep that in mind. So doing an ACL on an ASA is pretty straightforward. It is very similar to doing it on a router. So I'm going to go ahead and do the IP, access list. If I spell it right here. And I'm just going to call it RFC 1918. And deny. It will be IP. And then we'll put in our networks. 10.0.0.0. And here, you notice it's not wildcard masks in the ASA. It's like in the iOS routers, we have to do the inverse mask. It is the normal mask that we're going to be using here. So this is going to be an 8-bit. Oops. All right, so that's the source. Again, we're doing a source, and then the destination is going to be any. There we go. And then we can just bump that up, and we can put in the other ones. 172.16.0.0, and that one's 255 dot. So let's see, that is, we have to do a little bit of math here. 255 dot. 31 was the inverse, so 255 minus 31, 224. That should be it there. Oh, typo. .255 dot. .255, wrong octet, that's what it was. 224, there we go. And then 192.168.0.0, and this is a straight 16-bit, like that. 192.168.255, any, done. And then we have to do a permit any, so we don't block everything. There we go. So now if we do a show run, You should see that ACL. So we made an extended one, which is fine. You could do a source one as well, a standard one. That'll work as well. Then we need to apply it to the outside interface, which we put on. Where's our outside interface? There's our outside interface. So we have this kind of goofed up here. So gig 1.1 is supposed to be outside. Guess it didn't save right. And then gig 1.3 is inside. And then we are going to, we don't have to do this on the interface. We're just going to do access-group, the name, RFC 1918, out, interface, outside. That's it. And do a show run. There's our interface, and our ACL is down here, and you'll notice that the access group is right behind it. Okay, so just like that. So with that in mind, doing NAT on the number 5 is a little bit different. It's actually a lot different than everything else. So if you notice, we've got to NAT the DMZ servers to their public IP, provided their private IP. So here's their private IPs. So I'm going to do 1 or 2, and then you guys are going to be responsible for the rest. So let's map the 192.168.13 to 123.13, and what I'll do here is I'm just going to bring the firewall up so I can see everything. Alright, and with this we need to make an object, and if you remember from lecture from last week, the object is going to object network, and then we'll name it. I'm just going to name it what the server name is, web. Okay, and then I'm going to tell it what its host IP is, which is its local IP, 192.168.0.13, and then NAT, what it's going to be NATed to. All right, so it's going to be go from the DMZ, comma, outside, static, and then it's translated IP address 134.68.123.13, just like that. So we do a show run on that. You'll see after the interfaces you have an object, network, web, and that's its local IP, and then it actually puts it in 2 separate areas. Then we have object, network, web, and this is the NAT for it. So if we're going to do another one, let's do the mail server, and that's going to be object, network, call it mail, host 192.168.0. It is 21, and then NAT DMZ to outside, and then it's static, and then its IP is 134.68.123.21. Okay. Do show run, and you'll see after the ACLs you have your 2 network objects that defines the before the ACLs it had 2 network objects that defines the local address, and then after you have the NAT statements that are the same ones, they map together, and it has the public IP. So that is number 5. Number 6, we're going to create a overload pat and tie that to the outside interface along with an inspection ACL for the inside network. Okay, so to do that, we're going to make our internal, the same concept. All right. This time we're going to have make an object network, and we're going to call it inside. All right. And then we're going to, instead of have host, we're going to have network. I'm sorry, subnet. And then we give it the IP subnet, which is 10.0.0.0. And then the mask, which is 24-bit. All right, so that defines that. And then we're going to do a NAT open pair. This is going to be inside, comma, outside. And instead of static, it's going to be dynamic interface. Just like that. So, in essence, we need to go back and do a show run. Before our ACL, we'll have another network object. Access list. I'm sorry. Access list. I'm sorry. Object network inside. Here. 10.0.0.0 subnet, so that entire subnet, and then it's going to be dynamic to interface, and that automatically overloads. Okay, so that is different. That is different. All right, now we're going to make a DHCP pool for the inside network on number 7. All DNS requests should go through request traffic for your scope. We'll use 4222. All right, and use the inside interface as your gateway. So, to do that, we're going to use the DHCPD daemon. DHCPD, and we're going to configure the address pool range. So, we need to ensure that we don't overlap the AD ACS, which is .10. Alright, so we can start, there's a couple different ways you can do this. We're just going to start at a higher IP. Alright, so here we're going to have IP addresses, IP, so DHCP address inside, no, I'm sorry, that's 10.0.0. So let's start at 25. 10.0.0. We don't need to do too many. Let's just go to 50 inside. Oh, it's a dash. Little idiosyncrasies here. There we go. So, and then DHCPD. DNS 4.2.2.2. DHCPD. Now there's no option for a gateway. There's no keyword for a gateway. So if we do option, right, and then 0 through 255, if you look that up, what that option is for the default gateway, okay, you can Google this real quick. IP DHCP option default router is actually what it is. I believe it is option 3, if I'm not mistaken. Ready to configure DHCP. You also look this up through main domain server host. Oh, I have a default router there. I'm pretty sure it's option 3. RFC, Dhcp. There we go. Router option. For the purposes of this class, we're not going to be doing anything, and for time, just use option 3. Like I said, I think I'm 99.9% sure it is that. Option 3. And then the IP, and then the IP, which is 10.00.1. That's it. So, looking back at your DHCP config, which is right there, your address, your option, your DNS. Done. So that takes care of number 7. Set your firewall and router with the following credentials: username and password, and then logging. Again, pretty straightforward here. Same as a router. You don't have to worry about using password because there is no secret key command. Alright, that's that. It's automatically encrypted with an MD5 hash. And then logging. I think this is one thing we had a little bit of an issue because it wouldn't work. Yeah, it won't work in that. So you can use the logging command on your router, but not your firewall. So if you go to your routers, all right, and you go ahead and put in logging 10.0.10, that's it. Do that on the ISP router as well. Okay, so you don't have to worry about logging on the firewall because it does. This packet tracer does not have that command. Create an ACL on firewall 1 as follows. Remember, you used NAT previously, so you're going to create this ACL. You're going to create this ACL from the standpoint of inbound traffic coming from the outside, and it hits the ACL first and the NAT second. In a router. In a firewall, it NATs first and then it goes to the ACL. I don't know why, but it's the way it does it. So what you have to keep in mind is when you're writing this ACL for number 9, you're going to have to use the local IP, not the NATed IP. Don't ask me why Cisco does it this way, but all the other major manufacturers do it that way as well. So let's take a look at what this ACL is going to look like. Alright, so allow SMTP and POP3 to the mail server. So let's go ahead and create our named access list. Access dash list, and we'll name it filter. Oh wait, better yet, out dash in. That's a good one. That's a common name that you see in ACLs. And then space extended. Permit TCP any 192.168.0.21. I believe that is the IP. The mail server? Yeah, that's the IP for the mail server. Space EQ, and it's going to be for mail, so that's going to be port 25. Oh, I forgot the host. Do that. There we go. So the command, if we look at it here, because we created a new one, access dash list out dash in extended permit TCP any host EQ SMTP. All right. Oh, and it also wants POP3. So if we just up arrow and change that EQ from 25 to POP3, that'll do that. All right, so continue on with that ACL for number 9. The Blackberry Services, you might have to Google what Blackberry Services are, but for the most part these days Blackberry Services are nothing more than port 443. So keep that in mind. So for that one, for example, I'll do that one real quick. List out dash in extended permit, and that is from a host of 201.60.108.75 to the mail server, which is 192.168.0.21 EQ 443. All right, and that's all I'm looking for. Oops, I forgot the second host statement. I always do that. Extended permit, oh, TCP. There we go. So there we show run. We have 3. We have the SMTP POP3, and now we've added that 443 for the Blackberry Services. All right. So do CDNE. You guys get to finish that up. Number 10. Create an access list on Firewall 1 and allow servers on the DMZ to access the AD server via IP and AD service. So allow the servers on the DMZ to access Active Directory. So here, oh, by the way, on number 9, don't forget to apply it. So this is going to be the applied. I apologize. Going back to number 9. You can do access dash group. All right, this was out dash in interface outside. Don't forget to apply your ACLs. All right, so for the one here in number 10, we would write an ACL and then apply it with a we'll say we're going to create it, and it'll be DMZ dash in. And then we'll apply that to the in interface DMZ instead. Okay. Number 11, lock down all your devices with best practices from labs 1 and 2. So lock out. You can't lock out your HTTP engine on the routers. You might be able to do it on the firewall. But no CDP, lock out your aux port. Firewall doesn't have an aux port. Things like that. Okay, so that's what I'm looking for, a mix of that stuff. Finally, number 12, we're going to do a remote access VPN. using the CLI. So for this, it's a little tricky. Doing a remote access VPN, they have a guide here. If you follow this link, and it's going to crash on me. Shoot. You follow this link, and you will come to a step-by-step on how to create the remote access VPN in the ASA. All right. Good gravy. So if you ever want to kind of understand how to do this, a good troubleshooting step, show ver. So it looks like the version that I'm running here on the ASA 5506 is 9.6. ASA 9.6. And we do show, remote access VPN ASA 9.4. Oh, it finally came up. This will work too. Alright, this will work too. So basically here what you're going to do, it has a whole systematic way to do this for any ASA in the 5500 series. But at the end, at the end, configuration example, looky here. So just replace your IP information, your other information. Some of it you've already done. So we've already configured the interface, for example. But here, say we need to make our crypto policy. Crypto IKE v1 policy 1. Okay? Authentication, pre-share. You guys see what I'm kind of doing here? Encryption, 3DES. Actually, I want you to make it AES if you can. There you go, AES 256. Make it hard. Hash. Make it SHA. Group 2. That's fine. That works. Lifetime 43,200. All right. And then exit. And then crypto IKE v1. Enable. Outside. Alright. Okay, so you already have a local pool. You don't have to do that again because you already have a local pool that you have set up. But you can set up another one because we did our DHCP with the DHCP daemon. So I guess this is okay. Local pool. See, that's not going to work. So we don't have to worry about it because we already have a DHCP daemon set up. Yeah. So we did a username already. You can make another username if you want to. But if we do the crypto IPsec IKE v1 and make our transform set, they're naming theirs filter set, which is our first set. And then from here, we can pick whatever forms of crypto that we want to use in the IPsec layer. So let's pick the strongest, which is going to be ESP AES 256. Okay. And I think we can make 2 in packet tracer, so let's do the other one, ESP-MD5-HMAC. There we go, done. Alright, so anyway, continue following along this lines. Alright, and then you'll configure, if you go through and configure IKE v1, you probably will not have to configure IKE v2. You may run into some problems with packet tracer, but with this 5506 you might not. The only bad thing is, I'm just looking for the configuration. I will not, you can't test it, or at least I haven't figured out how you can test it in packet tracer. But that's the only thing I'm really looking for. I grade really leniently on that number 12. So if you follow that link, it will kind of walk you through everything that you need to do for that VPN. Okay, so that's it for Lab 3. I left you some things out there for you to finish up. Don't forget to finish them up. Don't just do what I did. You have to go back and complete the ACLs and complete the VPN and complete the natting. So don't forget that. I'll be looking for it. If you don't do it, if you just do what I did, you're not going to get full points. You've got to complete the lab. Okay? So that's it, everybody. That's the last lab. That's 4670. Hope you enjoyed the class. Hope you enjoyed the labs. Until next time, this is Professor Brown, and we'll talk to you later.